Good evening, everybody. Thank you so much for joining us this evening for Robert Zubrin's talk. My name is Ata Sirajuddini. I'm the Dean of the College of Science here at FAU. And I'm so excited to welcome Dr. Zubrin this evening. He's a respected author of a number of books, including The Case for Space and The Case for Mars, and a renowned expert on Mars. He's president and member of the board of directors of the Mars Society, president of Pioneer Astronautics, an aerospace R&D company in Colorado, former staff engineer at Lockheed Martin. He earned his master's degree in aeronautics and astronautics and a Ph.D. in nuclear engineering from the University of Washington. And as many of you know, he's actually here as part of a new course we've developed at FAU called Human Mission to Mars. We're using Dr. Zubrin's book in the class. We're covering all aspects of how to get to Mars, from getting there to establishing a colony to growing plants, water, psychological aspects of Mars and the mission to that planet. We think the class is pretty unique, and actually so did CBS 12. That station sent their reporter Lauren Oleski to our class a few weeks ago, and she produced 2 reports on the class. Both reports are available on the College of Science website. But I want to play for you part 1 and ask you to go to the website to watch part 2. So here is part 1.
There's a first of its kind class at Florida Atlantic University going on right now called Human Mission to Mars.
Yeah, we are on Mars right now. Let's get over to meteorologist Lauren Oleski. Lauren, you went back to college for the day.
I did, and it was awesome. I got to sit in on what I think is the coolest class, and this was the other day at FAU. The class is called Human Mission to Mars, and while I thought it was simply about just how to get humans to the red planet, I learned that a lot more goes into this mission than just blasting off into outer space.
How we solve problems in science.
Solving problems.
3, 2, 1, 0. Ignition.
With a little side of how to get to Mars.
But what do I really want to teach the students? And the answer is, I want to teach them how to do science.
Ata Sirajuddini, the Dean of the College of Science at Florida Atlantic University, created this class to teach students how to solve problems, no matter what their background is.
Biology with a focus of marine biology.
I'm a biology major with a focus in pre-professional studies.
Geology, Earth and Space Science.
A lot more goes into this course than even I originally thought.
Once you get there, how do you build a colony? How do you grow food? How do you make water?
And there are even more topics being taught, like the impact space has on our bodies. Does anyone have property rights? Will taxes exist up there? This class is unlike anything else taught on campus.
There's no other class here that's taught by 12 faculty. There's no other class here that involves, last count, I had 7 different departments.
This was really cool. So about every 2 weeks to a week and a half or so, they have a new teacher and they go over different subjects and different aspects of how to get to Mars. Like they'll learn how to grow food in one of the classes. The one I went to the other day was about the psychology. What kind of leader do we want to have? What's the best group dynamic we need for all of us to work together? If someone's angry, how do we, get over the conflicts?
So many questions.
It's really cool.
How did they address the topic of will taxes exist up there?
I haven't learned about the tax part just yet. Really, we were just kind of learning about psychology just the other day.
Okay.
We're going to dive into more about the psychology of what it's like to maybe, be stuck on a planet with just a group of people.
Okay.
Essentially forever. We're going to talk more about that on Monday.
I love this. Just something for everyone, no matter what your background is.
Yeah, and the students love it. We're going to hear from more of the students on Monday as well.
All right, so that was Lauren's first report. She had another segment about the same length that's available on the college website. It's at science.fau.edu. And I think that last lady's comment was most important, which is that there was something for everyone in the class. And we deliberately designed the class so there would be no prerequisites. You come in the class knowing essentially nothing. And we teach you all you need to know about these different aspects of going to Mars with the intent to teach you how to solve problems and to think about problems critically. So that was one of the most important aspects of the course. Now, before I bring Dr. Zubrin on stage, I'd like to ask all of you to silence your cell phones if you haven't done so already, please. And let's go ahead and welcome Dr. Robert Zubrin to the stage.
Okay. So, is the mic on? Is it on now? Yes, it is. Okay, great. So thank you, Atta, for that very kind introduction, and thanks to all of you for turning out to hear what I have to say tonight, and more broadly for your interest in this subject, because I think that this subject is the most important thing going on in the world today. And that while, okay, the newspapers don't agree with me on that, space gets a little coverage here and there, but it's not the headline today. From the point of view of future ages, it will be viewed as the most important thing going on today. For example, I mean, look, if I was to ask anyone here what happened in 1492, I think pretty much all of you would be able to say, well, that's when Columbus sailed. And that's true. But there were any number of other things that happened in 1492. For example, England and France signed a peace treaty in 1492. The Borgias took over the papacy in 1492. Lorenzo de' Medici, the richest person in the world, died in 1492. If there had been big-time newspapers in 1492, those would have been the headline items, not Italian weaver's son gets in some leaky boats and sails off to nowhere, comes back from nowhere. No. Okay, but we don't remember that stuff, okay? What we remember is Columbus, because he is what made our society here possible. And I think we have a little feedback here on this thing. So similarly, I think that 500 years from now, people are not going to remember Trump or Brexit or which gang of thugs won in Syria or whatever, but what we do to make their civilization on hundreds of planets orbiting hundreds of stars in this region of the galaxy possible, that is what they will remember. So anyway, I'm going to talk about this. I'm going to talk about the case for space, how the revolution in space flight opens up a future of unlimited possibility. Now that's a lot to talk about. A revolution in space flight, unlimited possibilities, the case for why you must do it. And I won't be able to cover it all adequately in a talk of an hour, or even any one of those three major areas. But fortunately, I have written a book on the subject, and they've got them here. And if after this talk you think what I have to say is worth looking into more, you buy them, I'll sign them. It's a win-win situation. And the profit goes to Florida Atlantic University. Okay, so let's start with the revolution. This is something here that many people may remember. You may have seen this the day it happened on your computer screens, or maybe even in person, because you're in Florida. But this is February 2018 you're looking at here. This is the launch and landing of Falcon Heavy. Now, this was a pretty cool thing to see, but unless you know the background, you don't know quite how cool this really was. This is really cool, and I'll tell you why. In 2010, Barack Obama called for a blue ribbon committee, which was headed by my former boss, Norm Augustine, the CEO of Lockheed Martin, to look into whether the Bush plan for returning astronauts to the moon was possible within reasonable financial constraints. And they came to the conclusion that it was not, because the required heavy lift vehicle would take at least 12 years to develop and cost at least, wait for it, $36 billion. So they called it all off. Musk went and developed a heavy lift vehicle in 6 years at a cost of less than $1 billion, none of which came from the taxpayers, by the way. And to cap it all, it's 3/4 reusable. So this was mind-blowing to people who actually knew what the expectations were. Okay, and so this is a shot heard round the world, and it has set off an entrepreneurial space race spanning 5 continents, okay? Because what Musk has done, in addition to introducing a very useful space launch system, is he's proven a point. And what that point is that it's possible for a well-led entrepreneurial team to do things that it was previously thought that only the governments of major powers could do. And not only that, do it in half the time at less than 1/10 the cost that they had considered normative. And furthermore, even do things that they had considered impossible altogether. Launch vehicles that come and land, okay? And so, now, of course, this was not the first shot out of Musk. The first was the development of the Falcon 9, cheaper than anyone thought, then making the Falcon 9 reusable, and now the Falcon Heavy reusable, and so on. And now they're on their way developing a vehicle to make this obsolete. He calls it Starship. We'll have a few words more to say about that, but that's a fully reusable 2-stage heavy lift vehicle that is now in development. Okay, so unlike the traditional aerospace companies who would stick with existing systems until they were paid by the government to try to improve them, he's more like the people who created this stuff, who have been racing to make their previous models obsolete before the next guy makes it obsolete, okay? And now he's been emulated. He's been emulating by people of his own general type. Jeff Bezos, the head of Amazon, he's got his company called Blue Origin. They're working on a reusable 2-stage vehicle called New Glenn. Richard Branson with the Virgin Galactic. And in fact, this is going on internationally. And we'll get to it a little more in a minute. And the effects have been pronounced. Let me give you one important aspect to this. Space age began in 1957 with Sputnik. From Sputnik in 57 through the moon landing in 1969, the cost of space launch dropped from absolutely astronomical levels to about $10,000 a kilogram to orbit by 1969, where it stood flat for the next 40 years. That is, from 69 to 2009, the cost of space launch did not drop at all. 40 years of stagnation. So yes, the initial space race, there was a lot of progress then, but then stagnation. However, in the past 10 years, since 2009, the cost of space launch has dropped by a factor of 5. It's gone from 10,000 a kilogram to 2,000 a kilogram, and if Starship is successful in meeting expectations, it'll drop to less than $700 a kilogram, a further factor of 3, okay? So this is astonishing. And furthermore, this revolution is not being limited to people of Musk's types, that is, billionaires with discretionary money who are seeking to make history. It has now become the province of working engineers. So this is Rocket Lab reaching orbit. This is a company started by a working engineer, a person with no more means at his disposal than any middle-class person, but he got $300 million of investment money behind him, and they reached orbit. And here's a real kicker for you. This is a New Zealand company. New Zealand doesn't even have a space program. Okay, New Zealand has reached orbit, not through the effort of its government, which has no space program, but through a private individual. And this is real. This is happening. They've reached orbit now several times. This is not science fiction fans talking about what they might do. This is happening. Okay, and these companies are all going to compete with each other. And I should add, by the way, that this is fully international. In March, I witnessed a launch in China, not of the Chinese government rocket, but of an entrepreneurial company in China called Link Space, where they launched up several hundred meters, and then they came back down and landed right at the center of the pad, okay? Putting it down like a crate of eggs, dead center on the pad. Now, they haven't reached orbit yet, but probably within 2 years they will. And they're going to be giving SpaceX a run for its money. And there's companies in Ukraine that are doing this. So these are all going to compete with each other. And as they compete with each other, they're going to be driving the price down. And the more the price is driven down, the more launches there are going to be. That's basically supply and demand. And furthermore, the more launches there are, the faster spacecraft technology is going to advance, both because there are more missions, but also because with the launch price going down, spacecraft designers will not need to be as conservative as they have been forced to be. For the past half century, the wisdom among spacecraft designers has been, don't use anything that hasn't been used before. Okay? Because if it's going to cost you $1 billion to reach orbit, you don't want to lose the whole mission because you try to get one little part here a little better than the last time. Okay? No. Okay. But this is a formula for stagnation. It's like the person who won't see any movies they haven't seen before because you don't want to see a bad movie. So you saw The Wizard of Oz when you're a kid. It's a good movie, right? Why take chances on anything else? So, you know, it's not really that encouraging a formula for progress, but now that has changed. And then there's another revolution that has occurred, which is a result of the advance of electronics and computers and such, which is the miniaturization of satellites. And we now have these things called CubeSats. This thing was initiated 2 decades ago. Initially just as educational projects. Oh, we'll make these little satellites and the students will have some fun doing some electronics and it'll be a blast if they see if it sends back beep, beep. Now these things are really doing missions. In fact, 2 of them went to Mars, okay, and relayed the entry, descent, and landing data of the NASA InSight probe. Okay, and these little spacecraft here, it's now possible to build 10-kilogram spacecraft that can do what previously took 1,000-kilogram spacecraft to do. And they don't cost hundreds of millions of dollars. They cost $1 million, $2 million, $3 million each. So now it is possible. So they're much cheaper to launch and they're much cheaper to manufacture themselves. So that what you're going to have is space missions launched not just by NASA, but maybe by Florida Atlantic University or, you know, medium-sized businesses. Okay, a lot more opportunity to get into space. Now, in 2018, there were a total of about 100 launches in the world, of which SpaceX got 24, which is incredible, actually. For a single medium-sized company to take a quarter of the world launch market. That's even a more impressive figure if you realize that half the launches were Russia and China and that they were not open to competition. So really half of the launch market that you could have competed for, they got. Okay, and that's great. And because they're driving the price down, there's going to be more launches. So probably you know, within a year or two, we're going to have 200, 300 launches a year, which is a very radical expansion of the launch market. But, okay, Starship. It's going for $700 a kilogram. And Musk, by the way, some of you may have seen his presentation in Texas a month ago, where he claimed he was going to have it reaching orbit in 6 months. Now, I don't think so, okay? That's Musk time. But 2 years, yeah, okay. And 2 years, or call it 3 years, whatever, that's really pretty short in the larger scheme of things. It's going to happen. So he's going to get the price of launch down to $700 a kilogram. But the price of air travel is $5 or $10 a kilogram. I mean, depending upon how far you're flying, your ticket might cost you $500, $1,000. And you, with your luggage, is 100 kilograms, so that's $5 or $10 a kilogram. How do we get down into that range with space travel? How do we make space travel the kind of everyday reality that air travel is today? Okay. Well, I think we need a bigger market than is available from satellite launch. And I'll tell you what I believe that market is. Travel. Global travel. Going through space, you can go anywhere to anywhere on Earth in less than an hour. Now, here is how I think about this. Okay, for the past 3,000 years, people have made money on the Earth's ocean. Now, some of them have made money by extracting wealth from the ocean itself, for example, by fishing. Okay, that's been a substantial business, and people have made some money doing it and had a livelihood doing it. But far more money has been made not by extracting wealth from the ocean, but by using the ocean as a low-drag medium of transport from point to point on Earth. That's been a much bigger business than fishing, okay? Because the ocean connects every port to every port with a relatively low-drag medium of transport. Well, space is a global ocean connecting every point on Earth to every other point with a zero-drag medium of transport. Now, when we had expendable launch vehicles, that was inconceivable that we would travel by expendable launch vehicles. That's like traveling by expendable airplanes. Okay, it's a non-starter. But now that we have reusable launch vehicles like the Starship, okay, or we don't have it now, but in the relatively near future, when we have it, okay, Starship is 2 stages. The first stage will launch and go up pretty high and pretty fast, but then come back and land at the same place where it launched from. The other stage then proceeds into near orbit and goes and lands on the other side of the Earth, where it lands, and there is another first stage operational there to send it back. So this is, for example, Los Angeles to Sydney in less than an hour. Okay. Now, I believe that initially these sorts of things will have to be in coastal cities because these rockets make a lot of noise, and so you'll actually have the launch pad 20 miles offshore, and you'll have little ferry planes taking you there and back, which will be quicker than the cab that takes you to the airport here. But that's how it'll go. And okay, now Starship, by the way, uses its propellant is methane, natural gas, and oxygen. And the reason why that was chosen, I've been a champion of methane oxygen propulsion for a very long time because it's the easiest propellants to make on Mars, and if you want to go to Mars and make your propellant to come back, that's the propellant to choose. And Musk also picked up on that for the same reason. And it's also a pretty good propellant combination as propellants go. But there's another feature to it which is of interest in this context, which is that it's the cheapest propellant combination by far. Now, if you're expending the rocket, it really doesn't matter whether your fuel costs $1 a gallon, $10 a gallon, or $100 a gallon, because you're throwing away hardware that costs much more than that anyway. But if you are not throwing away the rocket, then fuel costs matter, just as they do for aircraft. And this is the cheapest. And I looked at using Starship for travel, say from Los Angeles to Sydney, with, say, 100 passengers, and I looked at the propellant costs, and I said, well, if we say the whole mission, we're going to price it at 10 times the propellant cost, then you come out with a ticket price of like $20,000. Now, I personally have never bought an airplane ticket that cost $20,000. Okay. All right, so that's not me. But there are people that do. In fact, that is the current price for a first-class ticket from Los Angeles to Sydney. And all those people get for that extra 19 grand is a tablecloth, a bigger chair, and a couple of drinks. Okay, they still have to sit in that airplane for 14 hours. Okay, here you're getting there in less than an hour, and you got half an hour of zero gravity in the middle of the flight and a view of the blackness and bright stars of space out your window. Okay, that's a better deal. And I think it'll happen. And after a while, we'll get it down to $5,000 a ticket, and then I'm in for New Zealand. And the point here is this, okay, we may soon be at 300 satellite launches a year, but there are hundreds of intercontinental flights every hour on Earth. And so if you break into that market, we're talking orders of magnitude more flights. So these vehicles, though, are basically orbital vehicles. So let's say you're not really interested in going to Australia. Let's say you want to enjoy space. Well, I say, well, here's an excursion. We're just going to go into space and we'll orbit the Earth 3 times and come back down in 5 hours. Same price. Okay, so now you have day rides into space for this kind of money. If you want to spend a week in space, it doesn't make sense to keep the rocket plane up there a week because it could be making money flying every day. So now you're talking space hotels. 20 years ago, there is a fellow named Bob Bigelow who started a space hotel company, which didn't make any sense at that time because there was no way to get to it cheaply. But shortly there will be. So he was ahead of his time, but time is catching up to him. So that'll happen too, orbital research labs, orbital industries, all this kind of thing. But to me, I'm interested in space to open up the new worlds on the other side of space. How do we become not just a species that exploits immediate near-Earth space, but actually travels across space to other worlds? How do we become a spacefaring species? How do we go to the moon? How do we go to Mars? Okay, now, here's a bit of bad news. As you may have heard, the Trump administration has made a commitment to return astronauts to the moon by 2024. And there is one good part of this. If they took that deadline seriously, it would have the effect of forcing NASA to accomplish something material within a deadline in this way. However, that is not what is occurring. That is, aside from the fact that we could choose a better goal, which is Mars, and I'll get to that in a minute. If we're going to the moon, we should go to the moon. And what has happened, okay, NASA has 2 different modes of operation, a purpose-driven mode and a vendor-driven mode. In a purpose-driven mode, they spend money to do things. In the vendor-driven mode, they do things in order to spend money. Okay? Those are 2 alternative approaches to doing business. Now, the Apollo was a purpose-driven program. It was not a scientific purpose, it was a geostrategic purpose, but it definitely had a purpose. The purpose was to astonish the world with what free people can do, and they were going to get to the moon by 1970, and if anybody came in with peripheral programs, diversions, et cetera, it pushed out of the room. Okay? The science program, both then and since, that is the space telescopes, the rovers on Mars, the orbiters to Saturn, these are purpose-driven programs. You can quibble, they could have done it this way instead of that way, but they didn't send the rovers to Mars in order to give business to the airbag conglomerate. Okay? They used airbags on Spirit and Opportunity because this what the engineers thought was the best idea. But since the end of Apollo, the human spaceflight program, without a definite goal, has become vendor-driven. It has not become about accomplishing rational missions. It has become about distributing funds. So, for instance, if you take the shuttle program, shuttle flew about 130 times. Now, of those missions, there's 5 of them that I think were really great and absolutely justified 5 times over, which were the launches of Hubble, its repair, its upgrade. There's another maybe 10 missions that you could say, well, they were justifiable. They did something that we could look at and say, okay, that's worth a mission. But over 100 of those missions were just flying the shuttle to just fly the shuttle. Okay? They were literally doing things in order to spend money. Okay? And in that light, the Trump administration has come up with a vendor-driven approach to the moon, which maximizes cost and schedule. In other words, here is their plan, known as the Artemis program. It involves first building a lunar orbiting space station, which we certainly don't need to go to the moon. But then, after you have that, here's the plan for each lunar mission, which involves 4 launches 5 different flight elements, 6 rendezvous operations. That's 15 critical items, any one of which, if it fails, it kills the whole mission. In contrast, Apollo, for example, involved 1 launch vehicle, 3 flight elements, 1 rendezvous. Okay, so this is why such complexity. Well, it's like rewriting the school play to give every kid a part. Okay, piece of the action for all the stakeholders, and it's not the way to do engineering. Now, however, if they take advantage of the entrepreneurial space revolution, there's much simpler and more cost-effective ways to do it. This is the plan I call Moon Direct. I won't go through it in detail in this talk, but it basically uses a few Falcon Heavies to get the base going, and then after that, okay, there's one more revolution, which is a result of knowledge of the planets and the moon. We now know about materials on the moon and Mars that can be turned into resources, in particular on the moon, water that can be used to make propellant for the return trip. And once you have that going for you, you don't even need the Falcon Heavies anymore. You can do the recurring lunar mission with a single launch of the Falcon 9. Falcon 9 is the one that flew 24 times last year. In other words, twice a month. Okay, single launch of a Falcon 9 to get to the moon means you can go to the moon many times in the year, whereas the other plan were 4 launches for every mission. You'd be lucky if you have a mission every couple of years. So this is the way to do it. And the importance, by the way, of making use of lunar materials as rapidly as you can is that once you have it, you free up your heavy hitters, the heavy lift vehicles, whether it's the Falcon 9 Heavy or even SLS or even Starship, so that they can do other things. Okay, you don't want to, while you may need to use your heavy lift vehicle to get the lunar base started, you don't want to have to keep using it for that purpose. The analogy I give is, think Normandy Beach. Okay, you take the beach with your absolute best crack combat divisions, but once the beach is taken, it can be administered by rear echelon units, and your crack divisions can go and liberate the rest of France. Okay, so it's the same thing here. Okay, you use your heavy lift to get your foothold on the moon, and then you make lunar propellant, and then you don't need the heavy lift vehicles to sustain the moon base. Then they can be redirected to where they really should be going, which is Mars, of course. Now, I think Mars should be the primary goal, okay, of our generation in space, which is Mars is where the science is, Mars is where the challenge is, Mars is where the future is. Mars is the closest planet that has on it all the resources, all the materials needed to support life and therefore technological civilization. It is a place that we can explore, that the early Mars is very similar to the early Earth, so that if the theory is correct that life naturally evolves from chemistry wherever it has an appropriate environment, it should have appeared on Mars. Did it? And if so, did it evolve into the same kind of life that we have on Earth that uses RNA and DNA, or are those idiosyncratic methods of conveying information genetically in life? You know, in other words, we use the Latin alphabet, so do the Spanish people and the French and the Germans, but the Chinese use a totally different alphabet. It accomplishes the same function, but it works on different principles. Okay, so is life everywhere what life on Earth is? RNA, DNA, Latin alphabet life, or could you have Chinese life? Okay, you know, this is what you find out by going to Mars. Okay, so nothing like that is to be found on the moon. Okay, it's where the challenge is, which simply is not equivalent in returning to the moon. You're not going to inspire the next generation of youth with replicating things that were accomplished by their grandparents' generation. And it's where the future is. It is where you could develop a new branch of human civilization. Okay, we don't need giant futuristic spaceships to go to Mars. This is, what you're seeing here is the basic concept of what's known as the Mars Direct Mission Plan, which is explained in detail in my book, The Case for Mars, and in abbreviated form in the other book. But use a heavy lift vehicle. First, we send an Earth return vehicle to Mars, okay, with no one in it, and it makes its return propellant, methane and oxygen, out of Martian ice, water, and carbon dioxide, which is what the atmosphere of Mars is. Once that propellant has been made, the next launch shoots a habitat module to Mars with a crew of 4, 5, maybe 6 people in it. They go and land near the Earth return vehicle. They use this as their house and base on Mars for a year and a half while they explore. At the end of that time, they get in the Earth return vehicle. They fly back to Earth, leaving the habitat behind on Mars, so that over time, each habitat adds to the base, and before you know it, you have the beginning of the first human settlement on a new world, the germ of a new branch of human civilization on a new world. Okay, and there's a lot to be said about this. Beyond Mars is the asteroids. You may have heard that there are many asteroids that are quite rich in precious metals. Now, it's clear that, if all of a sudden you start taking hundreds of billions of dollars worth of platinum and exporting it to Earth, the price is going to drop. But the way this works, it won't drop to zero. Is the people who do this first will make lots and lots of money. Then other people will rush into the business, and as they do, the price will go down, and it will go down not to zero, but to the point where the business is no more profitable than the average business, at which point it will stop expanding. That's basically how it works. But this will lead to the development of the asteroids and human settlements in the asteroids. Then there's the outer solar system. Now, why would we be interested in settling the outer solar system? Well, there's something in the atmosphere of the outer planets which is of great interest. It's a isotope called helium-3. Now, you may have heard of helium-3 in conjunction with the moon. Helium-3 does not exist on Earth. It does exist in some quantities on the moon, although the total lunar resource of helium-3 is the ideal fuel for fusion reactors, okay? And before you get to, fusion reactors, what's that? Okay, forget it, it's not going to happen. I'll talk about that in a minute. But just for the moment, stipulate fusion reactors. Helium-3 is the ideal fuel for them, and it exists on the moon and not on Earth. But the total energy resource of helium-3 on the moon is comparable to, say, the resource of fossil fuels on Earth. It's important, but it's not exponentially larger than what we have. However, there's also helium-3 in the atmospheres of the gas giants, Jupiter, Saturn, Uranus, and Neptune. And the amounts of helium-3 available for mining there is like billions of times more than the total fossil fuel energy of the Earth. So it's an unlimited resource. Now, Jupiter, it'd be very hard to mine the atmosphere of Jupiter because it has massive gravity, and it'd be hard. You could get a spacecraft into the atmosphere of Jupiter, but not out. However, Saturn, Uranus, and Neptune, there's ways to do it. And now, but to come to the point, you say, oh, well, yeah, but that's all fusion power and it's never going to happen. Well, guess what? It's happening. And it's happening as a result of the revolution in spaceflight. How's that? Elon Musk is not interested in fusion power. Elon Musk doesn't believe in fusion power. He's a solar energy advocate. But what happened was, as a result of Musk's success in creating reusable launch vehicles, a number of heavy funds have looked at this problem and they said, wait a second, maybe the problem with fusion power was the same problem as reusable launch vehicles. Maybe the problem is not fundamentally technical, but institutional. And so there's a whole raft of fusion power startups that have gotten heavy investment. Here's Tri-Alpha Energy in California. They've gotten $500 million in investment. That's larger than the US government fusion program. And these people are moving very fast. This is not a sleepy bureaucracy like the Department of Energy, because in private industry, in a high-tech R&D company, cost is people times time. If you want to get it done cheap, you have to get it done fast. And so these people are leaping ahead. And I'm convinced we're going to see fusion from one of these companies before the end of the 20s. And I have to tell you, actually, I myself worked in the fusion program in the 80s. I was at Los Alamos. And I can remember one group lunch we had where the group leader said to us, he said, look, you know, when fusion power is finally developed, it's not going to be at a place like Los Alamos or Livermore. It's going to be a couple of crackpots working in a garage. And we all laughed, haha, because fusion power is hard, it takes big, expensive machines, and where a crackpot's going to get them. Well, if not a couple of crackpots in a garage, then a startup working in a warehouse, yes. And I think that's how it's going to happen. It's going to happen. And the thing about fusion is this. Fusion is an additional source of energy. You can use it to light light bulbs and do all the other stuff. But that's not why it's important. Okay, it's useful. But there are plenty of ways to light light bulbs. You can do it with windmills, solar panels, natural gas, coal, waterfalls, fission, whatever. Okay, a lot of ways to light light bulbs. But fusion power is not just that. It is a new kind of energy, and you can do new kinds of things with it. In particular, fusion rockets. Okay, and a fusion rocket can obtain an exhaust velocity as high as 7% the speed of light. And it is generally possible to engineer rockets that can get up to twice their exhaust velocity. So you're talking about rocket vehicles that can get speeds exceeding 10% the speed of light, which is not just a way to get around the solar system pretty fast. It is a marginal capability for interstellar travel. It's Alpha Centauri in 40 years, okay? Which, okay, it's not an easy trip, but some people will do it. They'll do it. And then finally, there's the prospect of terraforming. Okay, this is Mars. It's odd, it's green and blue. Okay, well, this is the Mars of the future. Okay, here's the Valles Marineris and so forth. Okay, and the ocean. Mars actually was once a warm and wet planet. We can see that from the water erosion features on its surface. It could be made, so again, we need to warm it. We know how to do that. We're developing quite the expertise in that area. And, but yes, through human engineering efforts, I mean, if we want to warm a planet on purpose instead of by accident, we know how to do it. And producing super greenhouse gases that are much more effective than carbon dioxide emissions. You could warm Mars, you could melt the water and create a biosphere. And there's a lot to be said about this, but I think that will do it. In my books, I outline a general scheme of how it could be done, although actually I don't believe it will be done that way, because the people who get around to do this are going to know a lot more than me. Okay, you know, for me to go through a terraforming plan, which I do, you can read it in the book. It's kind of like Jules Verne designing a moon mission. You may know in 1865, Jules Verne wrote a design for a moon mission. And he got an awful lot right. He launched from Florida. There was a crew of 3. They were in a capsule. They orbited the moon. They landed in the Pacific Ocean and were picked up by a United States Navy warship, all as actually happened 104 years later. However, the method he used to get them into space was heavy artillery. So, okay. Give him a break. He's a 19th century mind grappling with a 20th century problem. I'm a 20th century mind grappling with a 22nd century problem. So don't take my terraforming plans too literally, because I'm sure the people that pull it off, when they read my books, they'll say, well, how quaint. But the but they're existence proofs. But the fundamental principle is, you see, we're going to do it because we're life. And it's the nature of life to take barren environments and transform them that are friendly for the development and propagation of life. That's why life on Earth has been a success. Okay, it's life that put oxygen in the Earth's atmosphere. It's life that created soil on the continents. And no sooner does any dead place appear on Earth. Think of Hawaii coming out of the Pacific Ocean. Initially, it's just dead. But then birds fly over and they drop seeds and the place becomes lush. And then Polynesians show up and let loose some pigs, so there's something good to eat. And then Europeans come and build swank hotels, so there's a nice place to check in. This is what we do, okay? And it would be unnatural if humans, as the kind of bird, as it were, that the biosphere has evolved to take the seeds of life from here and transport them to barren islands out there and bring them to life, did not do that. So we're going to do it. Now, so that's some of the things we're going to do, and that's some of how we're going to do them. But now I want to talk about why it's imperative that we seize this opportunity. And there's a number of reasons that I'm going to give, and they include for the knowledge, for our survival, for the challenge, and for the future. Okay, now, for the knowledge, well, this is one that NASA does talk about, and with justification. So, astronomy, okay, space is the best place to do astronomy for sure. And astronomy has led our knowledge of physics. We learned about the laws of gravity and therefore classical physics through astronomy, much of electromagnetism through astronomy, relativity through astronomy, nuclear fusion through astronomy. And the reason why we learned so much through astronomy is because the universe is the biggest lab there is, and it does all sorts of experiments for us. And if you go up and look, you can learn a lot. And there's a lot that is left to be learned. And anyway, here, what you're looking at, that's the astronomer Sarah Seeger, who some of you may have heard of. She's giving the punchline of the recent Kepler mission looking for planets. And it found thousands of them. And the conclusion from this mission is 1 in 5 stars has an Earth-sized planet in its habitable zone. That's the punchline. 1 in 5 stars. There's 400 billion stars in the Milky Way galaxy. That's 80 billion stars in our galaxy have an Earth-sized planet in a habitable zone. We're living in a living universe, okay? And then, new laws of physics. There's things we do not understand about physics, including the most fundamental question of all, is why are the laws of physics what they are? In particular, why are they so fine-tuned to allow for the development of life? Because believe me, if they were a little bit different, life would be impossible. And there's no good explanation. Okay, and if we understand what caused the laws of physics to be what they are, who knows what powers over nature that would give us, what creative powers, okay, and so on. And also there's the question of biology. I alluded to possibly discovering new types of life on Mars, which means new kinds of biotechnology and all that implies. There's for our survival. Okay, now, here's something a lot of people don't realize about Earth, which is where it's located. The Earth is in space. Okay, this is a fundamental fact. The Earth is in space. And everything in space is moving around and crashing into each other periodically because it doesn't have good traffic control. Okay, and these smash-ups have repeatedly caused mass extinctions on the Earth. Of course, the most famous is the extinction of the dinosaurs. There have been many others. Okay, now these are some of the big ones. Okay, there's the dinosaur one right there. But this is not just ancient history. This is the past 25 years. In fact, December 18th, 2018, we had an impact over the Bering Sea, 150 kilotons, that's 10 times the force of the Hiroshima bomb, went off. Okay, now, we have to deal with this. Now, I do not have sympathy for the argument that has been advanced by some people that we need to go to space so that if the Earth is destroyed by an asteroid, there'll be some survivors somewhere else. To me, that is a repulsive argument. Okay, we're not going into space to desert the Earth. We're going into space to protect the Earth. And it is by becoming spacefaring, you have the capability of deflecting these things. But only by being spacefaring, because especially the more massive ones, the only way to deflect them is to deflect them when they're far out. So just a little push makes them miss. Okay? So this is another reason why we have to take this on. For the challenge, this is a graph that shows the number of STEM, that's science, technology, engineering, and math graduates in the United States during the period from 1960 to 1990. And what you see is here's 1960, here's 1970. These are the Apollo years. And look at this. The number of graduates doubles, and in the advanced degrees, it triples. And then as soon as the Apollo program is ended, it flattens. And this is actually a decrease because this is absolute numbers and the population is increasing. Okay. Why does this happen? Simple. It's because youth loves adventure. And a bold space program makes science the great adventure. And so the Apollo program caused millions of boys to go into science. And we have benefited from their efforts ever since. Now, I happen to be of that generation. I went into science because of Sputnik and Apollo and all of that. And I happen to be somewhat unusual in my cohort in that I actually ended up doing space. Most of the rest of them went off and built Silicon Valley, and that's why they're a lot richer than me. But they're the people that gave you this. Okay, now, a bold space program today, in my view, would have a much bigger effect than this, because the science and engineering professions today are open not just to boys, but to girls and to minorities in a way that simply was not the case in the 1960s. So not only would you have millions of little boy mad scientists making rocket fuel and robots in the basement to the great distress of their parents, you will have little girl mad scientists, which is frightening. But there it is. And that, by the way, if you're looking for what is the near-term benefit, what about the here and now? What about our needs? Intellectual capital is how you address all these needs. It is how you improve national defense, national prosperity, healthcare. All these things are best addressed through the development of intellectual capital. And there's no more power. You're not going to get more people into science by testing the kids to death with more standardized tests. Okay, but this will do it. And then finally, I want to talk about the future. Now, there's two futures I want to talk about. One is the far future, the 500-year future, the grand future, which is if we do what we can do in our time, yes, there will be new branches of human civilization on Mars and the asteroids and planets orbiting hundreds of other stars, and they will have new cultures, new forms of social organization. They'll have made numerous contributions to invention and technology. They'll have created literatures, languages, all sorts of things, and that is something grand and magnificent, and if you have it in your power to create something grand and magnificent, then you should. Okay, so that's the one thing. But I want to shift gears, and I want to talk about the more immediate future. And the immediate future that we hear about is one of threat. Global warming, resource exhaustion, asteroid impact. Well, these things are issues, I won't deny them, but none of these are what caused the great disasters of the 20th century. The great disasters of the 20th century were not caused by climate change or resource exhaustion or asteroid impacts. They were caused by something else entirely, which were bad ideas. And in particular, one bad idea in a number of different formats. And what that one bad idea is that there isn't enough to go around. That there's only so much here, and there isn't enough to go around, and sooner or later we're going to have to fight over it. So, for example, see this book here, Germany and the Next War. This is written by Friedrich von Bernhardi, one of the chief intellectuals of the German General Staff, international bestseller in 1912. Okay? And what he said is, well, there's only so much here, and as far as Eurasia is concerned, either we, the Germans, are going to get it, or the Russians are going to get it. And so we're going to have it out with them sooner or later. Should it be sooner or later? Well, clearly sooner, because we need to knock them out before they industrialize. So 2 years later, they take advantage of the pretext of the assassination of the Archduke to initiate World War I, which is the seminal catastrophe of the 20th century, because it set in motion the forces that did the rest. 1939, Hitler, even more hysterically, the laws of existence require uninterrupted killing so that the better may live. Germany needs living space. Bunk. Okay? It was bunk. Deadly bunk, but bunk. Why? How can I say it? Well, they never needed living space. Germany today is smaller than the Third Reich. It has a larger population and a vastly higher standard of living. Why? Not through successfully acquiring other people's land and cattle, okay, and so forth, and stealing what they had. They were unsuccessful in that venture. No, it's through the advance of science and technology, and some of those contributions were made by Germans, but many more were made by people of many other nations, including groups that they were trying to exterminate. Okay, so that was all nonsense. Okay, but it drove a catastrophe. And then today, I can tell you for a fact, because I have spoken to them myself, that there are people in the national security establishment in Washington, D.C. who believe that war with China is inevitable. Why? Because there's 1.3 billion of them, and if they develop so that they have a living standard comparable to us, so they all have cars, there won't be enough oil in the world. Okay? And you can bet your bottom dollar that there are people in Beijing, their counterparts, who look at this problem from the opposite side of the chessboard and think exactly the same sort of thing about us. And if this kind of thinking is allowed to prevail, there's going to be war. Okay? Unnecessary but catastrophic war. Much worse than the 20th century wars, because we have much more effective weaponry. Now, this is a nonsensical point of view. Okay? It is not true that there is only so much to go around. The theory that there's only so much to go around breaks down to the Malthusian theory, which says the more people there are, the lower the standard of living is going to be, because there won't be as much to go around. Now, this is counterfactual, as this graph shows. Okay, here is the world's population. Here is GDP per capita in inflation-adjusted dollars. And what you can see is as the world's population has gone up, the standard of living has gone up. How's that possible? I'll tell you how it's possible. It's possible because product per capita is equal to productivity per capita, and productivity per capita is determined by technology, and technology is created by inventors, and the more people there are and the higher their standard of living, the more inventions there are, and inventions are cumulative. Okay? And that is why this has occurred. Okay? But convincing people of this is very difficult. You know, in 1972, there was a very prestigious group, some of the older people here, people my age, we're the older people now, remember the Club of Rome, who, this was a bunch of very prestigious people, and they had a computer which made them quite authoritative. They could not be wrong. And they predicted that we would run out of everything by the year 2000. They did the calculation. These are the oil reserves. This is how much we're using each year. It will all be gone by the year 2000. This is the copper. It will be gone by 1997. This is the zinc. It will be gone by 2002, et cetera, and so forth. Now, the year 2000 has come and gone, and none of these predictions have come true. Okay, fine. But And the reason why none of them came true is what is and what is not a resource is determined by technology. There's no such thing as a natural resource. There's only natural raw materials. It is resourceful people who turn materials into resources. But here's the punchline. About 15 years ago, the gang held a reunion. And they actually published the proceedings of this conference. It was called the Limits to Growth Revisited. And in the proceedings, he said, look, a lot of people think we were wrong because none of our predictions came true. Okay. But we were right. We have to be right because there's only so much to go around. The Earth is finite. We're using things. It's all going to get used up sooner or later. Yeah, we missed a few things. We didn't know about, they discovered oil here. We didn't realize that was going to happen and blah, blah. We have to be right. Well, they were wrong. Okay, and similar predictions made at every point in history have been wrong. But it seems self-evident that fundamentally they have to be right. And to me, the problem is like convincing someone who does not know mathematics that there's an infinite number of points in a line segment. Okay? If you know math, you know that there's actually an infinite number of points in a line segment, say between 1 and 2 on the number line. If you don't know math, that doesn't seem to be possible, but it is. Okay? So you really have to understand things a bit more deeply to get that. However, anyone can see that a line that goes infinitely in both directions without end has an infinite number of points. That is quite clear to anyone. And so the issue is this, is we're not going to Mars in order to get oil from Mars. Okay, we'll probably get inventions from Martian society, which will be a group of technologically adept people in a frontier environment where they'll be inventing all kinds of stuff for their own use and licensing it on Earth and contributing to progress. But no, we're not going to get oil from Mars or, so forth. But what we're going to get is proof that it is not true that there isn't enough to go around, that there's only so much here. Because it'll become clear to people that the Earth is not limited because it comes with an infinite sky, and it's wide open. And that's the case for space. So I'm delighted to take questions.
Thank you very much, Dr. Zubrin. That was an excellent talk. We have some microphones set up on each side. Auditorium. If you'd like to come forward with your question, please do so. This gentleman in the front right here, would you like to come forward and ask your question?
How you doing, sir? Thank you for coming out. Really appreciate that. My name is Jake. My secretary's here as well. We're with the Aerospace Experimental Association here at FAU. And you mentioned CubeSats. We're actually starting next semester launching the CubeSat Launch Initiative at FAU. With your experience, is there any tips that you can provide for starting out for designing and launching a satellite?
Okay. Test a lot. Okay. Get a vacuum chamber. Test, especially the thermal issues. And also seek advice from others who have done CubeSat projects.
Awesome. Okay. Thank you, Professor.
Right.
In the case of terraforming, where we're changing Mars, if you relate this to, I guess, the idea of invasive species, of how we're changing the natural habitat, how do you think that changing space, and in that relation, do you think that could do more harm than good, and what is your opinion on that?
Well, I'm not quite sure what you're getting at, but let me bring up an argument that some people make and my counter to it. Okay, there are some people who say that if we're altering the environment of Mars, we're committing an act of environmental sacrilege. And isn't that wrong? Well, look, if I came to you and said, why don't we take the Earth and make it like Mars? You would say, whether you're an environmentalist or, hardcore developer, you would say, that's ridiculous. That's insanity. You're going to take this wonderful, lush Earth with all its different life forms and turn it into a place like Mars, which is a desert with maybe some bacteria living in the groundwater underground. That's criminal. And I would agree with that assessment. So if turning the Earth into a desolation like Mars is a horrible act, then taking a place that is a desolation like Mars and turning it into a living Earth is a wonderful act. It's an act of creation. Something isn't wrong just because people are doing it. That isn't a living world better than a dead world? I think it is.
Hello, I'm Victoria, and I'm actually with the FAU High School program here. So I'm just here to learn, and I love space, so it's always been a passion and interest of mine. And one question that came up was if we are to go to Mars and inhabit the place, and eventually, bring in, plants and other life forms to inhabit Mars as well. How would we go about, or how would there be any evolutionary changes for the life here to adapt to the life, environment on Mars?
Yeah, that's an excellent point. There certainly would be. Because even if you gave Mars an atmosphere and you warmed it and you had liquid water and all this, Mars would still be quite different than Earth. For instance, it would always have 1/3 gravity. So if you take species from Earth and bring them to Mars, because we'll go with ourselves and our domesticated animals and many non-domesticated animals. Raccoons will come to Mars. You can bet on it. But in a new environment, they will adapt in new ways. So when an animal moves into a new environment, it readapts, it re-optimizes for the new conditions. So you will get speciation. And I think this is a good thing. I'd like to see more new species of things out there in the universe, and to give animals and plants an opportunity to create new species. And eventually, of course, the first thing that will change among humans will be culture. Okay, that will happen way before genetic change occurs. Go to a new place, start a new society, there'll be new cultures develop, and possibly quite a few new ones, because Mars is big enough for more than one society. But eventually, especially as humans go out to the stars and go to many different kinds of planets, some with less gravity, some with more gravity, I believe that humans will speciate as well. And so, if you watch Star Trek, okay, you see these alien races that are all pretty much like humans, except some have pointy ears or blue skin or this or that, okay? And it's really, and they can even have relationships and children with each other, right? Like Spock, okay? But now it's really extremely unlikely that any genuinely alien species could, shack up with a human and have children. But if you think of the far future when humanity has gone to the stars and diversified so that these races are not actually alien races but different varieties of humans that have differentiated out in space, perhaps you might see something like that. And who knows, meet someone you like on Match. Probably, yes. Not through intention, but, I mean, come on. They'll get there. Yes.
What is your take on Earth becoming like its sister Venus, and how we can avoid it, and if it's unavoidable, and is that one of the reasons why you want to go to Mars?
Okay. I think it's extremely unlikely that Earth becomes Venus through anthropogenic global warming in the relatively near term, that is for the next 1,000 years or anything like that, because it has a lot of negative feedback to resist that. However, although there could be other consequences, not as drastic as that make it worth avoiding. But in the long term, in 500 million years, the sun is continually getting warmer. The sun, at the early history of the solar system was only about 70% as strong as it is today, and then 80, 90, and so forth. And if the sun gets to about 110, that is about 10% more strong than it is now, it will overwhelm any negative feedbacks that the biosphere has against global warming, and yeah, we could become too hot for life. So that's a more distant prospect, but certainly in the ultimate sense, either we become spacefaring or we become extinct.
Thank you.
Okay.
Hello. I'd like to ask a question. In the past, the space programs were very much driven by political competition between, for example, Russia and the United States for the man in space and first to the moon and so on. You're describing many things that with imagination could be accomplished. How much do you think they'll be limited just by a nation, for example, wanting to be the first on Mars and that's it, and it won't do all these other things that you're talking about beyond that?
Well, I hope I don't offend the sensibilities of people here if I offer my opinion that we've had a deterioration in the quality of the political class in this country. And I'd be delighted if they were to get it together enough to commit to send humans to Mars and do it as they did Apollo, okay? But the generation that did Apollo, that is of political leadership, were the same people or the younger brothers of the people that won World War II. And they knew how to pull together across party lines to accomplish great projects, whether it was winning the war, the Manhattan Project, the interstate highway system, or going to the moon. And that seems to, that virtue seems to have faded. And this senility on their part has actually been one of the driving forces that created a need for this entrepreneurial revolution. In the 1960s, looking for an entrepreneurial savior like Musk wouldn't have even occurred to anyone because the government was doing such a great job in pushing the frontier in space. Now you say, look, Elon, where are you? Please. No, with the entrepreneurial revolution, we're going to see a much more multifaceted space program because, for instance, Musk is focused on Mars, Bezos is focused on the moon. Okay, and if there's 100 different players focused on different objectives, then there'll be 100 different objectives pursued. Sir?
How was Mars made?
Oh, how was Mars made? Okay, well, I wasn't there at the time, but Mars, to the best of our knowledge, was formed along with the other planets at the same time as the rest of the solar system. That it's believed that there was a whirling cloud of gas which condensed, the biggest part of it condensed at the center to form the sun, and other parts condensed to form planets at different distances from the sun. And it's not really well understood exactly why the set of planets that we have were formed in the sizes that they formed at and where they formed at. It used to be that people thought they knew because they had to figure, well, of course, we'll have the rocky planets early in and the gas planets on the out, because that seemed to be the pattern. And they had all sorts of explanations on why it must be that way. But then the Kepler telescope discovered thousands of other solar systems that were arranged every which way, and so now all those theories are out the window. So it could be that there isn't a rule, except for the fact that planets do certainly form. And we also see that every big object in our solar system has little planets going around it. For instance, Jupiter has over 60 moons, and so does Saturn. And Uranus and Neptune have a dozen or so each. And of course, the Earth has one, and Mars has two. So it's pretty much the case that every large object in our solar system gets other objects going around it. And of course, the Sun is the biggest object. So Mars was formed at the same time as the Earth. But here's an interesting thing. Because it's smaller, Mars cooled down faster than the Earth. So that, when Earth was first formed, it was all molten. It was too hot for life. It started cooling down. So did Mars. Mars cooled first. Okay, so life would have had an opportunity to evolve on Mars before it appeared on Earth. So they were there first.
Thanks, man. Hi, how you doing? My question actually has a little bit to do with the cooling down of Mars first. You had mentioned terraforming on a planetary scale, potentially, on other planets like Mars, and that hinted at our superior knowledge at warming planets. And so my curiosity is in planetary protection against like solar radiation, for example. How would we do that on such a large scale? Because I know that on a smaller scale with the bases, we'd be using water-filled walls and things of that nature to dissipate that. Is there anything?
How would you be protected on Mars against radiation?
Correct.
Yeah, well, if you thicken Mars's atmosphere, that's a lot of protection. The main thing protecting you from space radiation is not the Earth's magnetic field, it's the Earth's atmosphere. You have standing on top of you right now, in terms of air, a mass equivalent to 33 feet of water. You got 33 feet of water sitting on top of you here. That's what's shielding you against cosmic rays, not the Earth's magnetic field. And if you had a third of that, if you had 10 feet of water, that would still be a damn good shield. So if we create an atmosphere on Mars, that would create a very substantial shield to the surface. Even the thin atmosphere that Mars has right now, which is only 1% as thick as the Earth's atmosphere. 1% of 33 feet is 4 inches. So that's like 4 inches of water, but that's looking straight up. Okay, if you take the average over all the angles that things can come into you from different directions of the sky, the 2 pi steradians of the sky, it actually is like 2 feet of water, which means actually that on Mars, while there is cosmic rays do make it to the surface, solar flares don't. But certainly once you terraform it, it'll be a massive shield.
So I know there's a lot of good questions out there. I'm sorry we can't take them all right now. I want to save some time for the book signing. And Dr. Zubrin will be in the back there signing his book, Case for Mars and the Case for Space. Let's thank him one more time for an excellent talk.